again, we're on 1.4. We're using technology today to graph and use tables to solve equations, solve inequalities when it's greater than and less than and all that. If you were to go to your textbook and go under math tools, they would have the Desmos calculator available that you could use. And Desmos is nice. I'm going to show you just here. I'm going to show you how it would be used. You do not have to pay attention, write down, or anything like that for it, because Desmos is very much, you just plug it in the way it is and it's there. I will not allow you to use Desmos on a test. They don't allow you to use Desmos on the ACT. They're working on allowing that to happen. They have to figure out how to lock down browsers and things. Desmos, you just plug it in there and it does it, but it does not do all the other things that the TI does. So it's nice, but it's not perfect. So I'm going to show you on here. I'm just going to put x squared plus 6x plus 5 is greater than equal, and that would be under my thing, greater than equal to 0. And I got this picture. Well, what shape should this x squared plus 6x plus 5 be? It should be a parabola. That does not look like a parabola, so maybe we're too close. That is not a parabola, is it?
No.
So let's figure out why it did what it did. And when you figure out why, you're going to be like, oh, I see now. So I'm going to go and I'm going to take away this right here. Is that a parabola?
Yeah. Yep.
Okay. So when I ask if it's greater than equal to 0, I want to know where it's above and below the x-axis, right? And that happens at what things on a graph? The x-intercept. And Garrett is gone too. Has he been gone all day too?
Yeah.
Okay. I just spaced out that he was gone. And it tells me, look, I can put the finger on there and it says -5, 0. See that?
That's awesome.
That's awesome. But why did it do what it did before? But I want to know where it's greater than 0. Yes, greater than equal to 0. Why does it do this? Because everything to the left and everything to the right of those intercepts are greater than 0, correct? So it's just showing you the answer to the question that you asked and nothing else. So the other thing that Desmos does and TI doesn't do, if you want to know like when this is greater than another equation, I would just put the other equation in, x 3 plus x. And it's going to show me, weird, but it's going to show me, and then I can see it. But if I really wanted to see what was going on, I would put 3 plus x here and take away this, and I would see the two graphs individually. Now, if I wanted to know when the square was less than, that would, okay, when this 3 plus x is greater than, well, it's only greater than where? Right between here and here, correct?
Yes.
And then every other time, that linear line kind of came like my x-axis, didn't it?
Yeah.
So Desmos is nice. I can just click on things and it tells me. I don't have to really know how to use it. I just kind of do it. And there will be activities that we do at Desmos that will be very fun and interesting to do. There's an activity that once we know a bunch of equations, I would like to spend time and have you make a picture with all the equations. And so, but right now the TI is what you need to learn how to use for the ACT. That is what is accepted on the ACT. So that's what we're going to do. So you should have your calculator in front of you. Hopefully you all have batteries in it like you should. And you might want to write this equation down before we lose it. We have x squared minus 4x plus 1 equals x minus 2. Because as soon as I hit the calculator, it's going to go away. So you need to write that down. We'll just use it. And it won't even let it turn off. Okay. Just like roll them a little bit. You can put more in later. Did you put them in the right way?
Yeah. Are you sure?
It turned on when I put them in at first. I keep just wanting
Yeah.
Okay, so everyone got that written down so we can go in?
I got it.
What's this called?
The- This is just continued of yesterday. You're solving systems and inequalities, but we're now going to use tables and graphs. Okay, ready? You're getting there. Okay, you'll be fine, Addie. Okay, so I have my calculator here. And when we need to do something to graph, let me go back to the home screen so you can see what it would look like. That's what yours looks like right now, yes? Okay, so when we want to graph something, if you look, I'm showing you over see on the side, that's my graphing calculator. That's the pad. And then I have these keys at the top right under the screen. Anything that is to do with graphing, that's where you find it. Okay? Things that are in blue, I have to hit what button first? Second. Okay. So I want to graph something, so I have to do y equals. Now, Desmos, I didn't have to do y equals. It didn't have to be set equal to y. In here, everything has to be set equal to y. Improves your equation solving skills tremendously. Okay, so if you have something in there, you can just hit clear. So we're going to put that equation in there, but we have to put it in two separate times. So we have x squared. Now, right next to alpha, there's a button that says xt theta n. That is the button you will use for any variable. No matter what the variable is, you're going to use xt theta n. You can only operate in terms of one variable in this calculator. Got it? Until you go to an 89 or a Inspire, you are in one variable in a TI calculator. Other reason why Desmos, it can operate in two. So there's x. Then there's a button right above log, right here that says x squared. You can hit that, or right above division is a caret, and you can hit caret 2. The x squared will give you the 2, and you're great. The caret will let you do any other power besides 2. Natalie, if you use the caret, you have to arrow out of the exponent. If you don't, you'll stay in. Use the caret. I want to show you. The caret's right above division. The caret, everyone find the caret. It's right above division. Looks like a caret. That's what that's called. Caret. Okay, you put caret and then 2, and there's your second. Now, Natalie, you have the same picture I do. You have to arrow over to get out of the exponent.
Oh, okay.
Okay. What?
The X is.
The x is right next to alpha. It's a theta. That's a theta. Evan, what? Okay, and then you need squared. So the right above division is a caret. Hit that, and then hit 2.
I do that.
You should have x caret 2. Your calculator would look a little bit different than mine.
Okay, yeah.
Does it have x caret 2? Yes.
Okay,
That's an old calculator. This isn't. So that's
why I was.
if you want the pretty colors, you got to buy a calculator. Okay, so x squared minus 4x. Now the other thing is this is a minus next to the 6. Below the 3 is a negative. And you only use a negative at a beginning of a function. Got it? Okay, minus 4 plus 1. Okay, so that was the left-hand side. Now just, you can hit enter or you can arrow down at this point. It doesn't matter because we have to put in the other equation. And that was x minus 2. So x minus 2. And we want to know where these two things are equal. Where are they equal at? Where are they what? When they intersect. So we're going to look for that. So now hit zoom. It's right in the middle of your top buttons. And we're going to hit 6. 6 is a standard screen. It's negative 10 to 10, negative 10 to 10 on the Y's. So just hit zoom 6. And zoom is right under your screen. Anything to do with the graph is under your screen. Okay, zoom in 6. You can arrow down to 6 or you can just type 6. Okay, so I want to know where these things are equal. Will they intersect how many times? Twice. So on here, you'd be like, I don't know, maybe 4 and a fourth, and that you can't, like, it's a total estimate, correct?
Yeah.
Just like it was for you yesterday, unless they were nice points. So, above, you see the button trace.
Trace, yes.
Okay, hit trace, and hit left and right. See what happens. What happens? You're on the curve, right? Hit up or down. Hit up, and see what happened. It moved to the other curve, didn't it?
Yeah.
And it's showing you points.
Okay.
And I could trace, and I could do this, and I'm still an estimate because it jumps, right? What do you see above trace in blue?
Trace.
Calc. It calculates it. Do you think that might be a more exact answer?
Yeah.
Yes.
Mine doesn't have like anything on it.
Mine has
Just
no
an empty
one.
graph.
Did you put y equals?
Yes.
You put the equations,
Yeah.
or your equal signs in black boxes.
Yeah. Look,
It's
I
big.
can't see it now.
You gotta hit y equals.
I forgot how to check this.
No,
If you just type in your y's, you can just click graph and then click y again, and it'll do it like that.
Okay, how do we get y
Right, but I
equals?
wanted you to zoom. I wanted you to have the screen. What?
How do we get y equals?
You hit the Y equals button.
You hit the y equals button. Right above the screen. Anything to do with the graph is right below the screen.
Okay. Should be on.
You should have y1 is x squared minus 4x plus 1. y2 is x minus 2.
Are we gonna put the exact decimal?
We're going to find the exact answer, yes.
You press 0, go to the
6. Now, do you have a picture?
Here we go.
Okay. Now, trace was okay, but it wasn't going to give us an exact answer. But anything we want an exact answer, we hit second trace, which gives us calculate. Look at all the things it can do for me. It can find a value. That means I can plug in any x, and it can tell me the y. It can find the zeros. What are zeros? X-intercepts, right? And if I wanted a y-intercept, I'd just plug in 0 for x, and wouldn't that give me the y-intercept? Okay, what is this? A minimum, right? Okay, maximum is the uppest. And then you have uppest. I don't even know where that word is. Highest. 6 and 7, you got derivative and integral, which you won't need to do. But what is 5?
Intercept.
Intercept. Is that what we want?
Yes.
Okay, so you need to arrow down to 5 or just punch in 5, either one.
Wait, where do you go?
Does it want the first curve?
Okay, now just wait. We gotta wait because I'm not gonna repeat myself 6 times. Okay, on here, when you do this, you either have this equation, it either says y1 or y2 up in the top left. Do you see that? If you hit second trace intersect, you should see that on your screen. Second trace intersect. It should come up with an equation up in the top left, and it says first curve on the bottom. Okay, just push enter. Now what happened? It said second curve on the bottom, and did it move you to the second curve?
Yes.
Yes, so hit enter. Now it says give me a guess. Now we have 2 intersections on this, yes? Whichever one I want to be closest to. So you move it left or right to get close to that intercept and hit enter. So I have 0.697, so 0.70 for my x and negative 1.30 for my y. Do you have approximately those numbers?
Approximately.
Okay. Okay, we've got another one, so if you got lost on this one, we've got another one. Okay, now it's approximately, the reason I say that is sometimes my calculator will come up 0, and the next time it will come up like 1 point, and then 10 digits, and then e to the negative 18. Okay, e stands for exponential notation, which is the same as scientific notation, and if I'm taking a 1 point whatever number to the negative 18th power, that's 17 zeros before the 1, isn't it?
Yeah.
So is that really close to 0?
Yeah.
Yes, extremely close to 0. 0.18 or 17 zeros and then 1. So you have to, they won't always just come out with a digit. They'll, I don't know, it's temperamental. And you won't always get the same number twice. Okay, now we're going to do it again. So I have to hit second trace. I'm looking for the what? Intersect. So I hit 5. And it says first curve, you hit enter. And guess what? It's going to jump to the second curve. And you hit enter. And I don't want the same x-intercept, or not x-intercept. I don't want the same intercept, do I? I need to go where? Closer to that one. And then hit enter. I got approximately 4.30 and 2.30.
Yeah.
The zeros on the screen look like
By golly, is our numbers supposed to be the same?
It will be approximately the same.
I have the same exact number.
Yeah, you may have the same exact numbers and you may not.
Just depends on how cool you are.
Yep.
Swap.
And it's a judge because it's fluid. You know, you could be cool one time and then not the next. Okay,
I got cool votes.
so you guys ready for another one?
Yeah, sure.
Okay, so we're going to go to y equals again. Oh, the other thing is, okay, I am stuck on this problem. I don't even know what I'm doing. I can't even think about it right now. I don't want to have to re-put them in when I come ask a question, right? So if you notice the black boxes around the equals, if you, like I'm pointing at them because you can see me point, the black boxes on the equals right here, if you hit the back arrow, you would highlight that and just hit enter, and then I could go down and hit enter, and you notice that black box is gone. You've just shut it. If you graph, it's just shut off. So then you could come in and you're like, what is wrong with this? Well, oh, you used a negative instead of a minus. I can tell you, I mean, just different things like that. Okay, so if you're having problems, I would always suggest retyping it in because sometimes that fixes it, just because we make mistakes. Okay, so we're going to do x plus 3.
Simpler.
Yeah, so just clear. Don't use delete unless you're like in a problem. Deleting things, like when you are on a list, you could delete it and then we have to add back in the list. So just hit clear, it's safer. Okay, so x plus 3 and the other equation is 7 minus 3x. And we want to know when x plus 3 is greater than 7 minus 3x. Now this is where you guys need to pay attention because Natalie and mine is going to come up fuchsia and red. Your guys is going to come up black and black. And black, and black, and black. Okay, so you got to pay attention. So, and I'll show you how to check which one's which if you can't remember. So we want to know when x plus 3 is above 7 minus 3x, correct? So we're going to look for the intersection and see where they're at. So go ahead and hit zoom 6 again. Just, it should still be on zoom 6, but just so you can. Now, it drew it and you lost track of which one was which, right?
Yeah.
Okay, so we have x plus 3. So we should know that it started at 3 and goes up by 1. So this right here is x plus 3. But if you forget, if you hit that trace, see this?
Yeah.
If I hit left and right, I stay on that equation. If I hit up or down, it goes to the other equation.
Okay.
So that can help you. Okay, so we want to know when x plus 3 is greater than, yes?
Yes.
So where does that happen at?
After the
After it intersects. So how am I going to figure out where it intersects at?
trace.
Not trace, but second trace, right? Calc. So
Oh,
second trace, you guys do it all on your own.
And then plot it.
No, not plot it. You won't plot it. You'll just find the intersect.
Yeah. I could have said concentrate and plot.
Oh, okay, yes. I thought you said plot it. I got 1, 4.
2.
Good job.
Do we get time hitters on the test?
If on the test, you're gonna have to graph them by hand. You're gonna have, if we have a technology test, it will be like a separate day We'll have like a calculator test and a non-calculator test. The calculators are all practical. Like if you were in a position where you did this, needed to know, you would use technology. You would use a computer program, you would use a graphing calculator. But I have to check whether you can graph equations on your own and things like that. Does that make sense, what I'm saying?
Wait, how do you even like do that? I don't know how you use the trace bar.
Is calc, it's the second trace. Trace is right below the,
Yeah, it is.
These calculators are like so.
they're really not after you, I mean, because you just kind of do the same things all the time. But it's you guys haven't used them. And when I found this box, I wanted them in your hands now so you can use them and manipulate them. And like I said, if you're going to stay in math, getting your own would not be a bad thing to do.
See, I talked to my sister. She has one.
Yeah.
She hasn't used it in high school.
She hasn't?
She hasn't.
Yeah, that's right.
Well, it just depends on your, well, in high school, she may not use it a lot, but in college for classes, you will use it. So it's not something you're going to buy and never use again. So it's up to you. It's a personal choice. It's a financial choice. But I'm saying if you can, I would encourage you to if you expect to go on. Okay, so let's do another one. We had like absolute value things we had to graph, right?
Yeah.
What does an absolute value look like?
A V.
A V. So we need to figure out how to do that. Okay, so we're going to go back to y equals because anytime we want to graph, we have to solve it for y and go to y equals every single time. Do not come to me and ask me, how do I graph y squared plus 6x squared minus 7? It's not set equal to y. It's y squared, right? Until you set it equal to y, you cannot put it in this calculator. Okay? So we are going to do negative x squared. So we have to put negative, and the negative is right next to the decimal. Negative x squared. If you make a mistake, I'm just going to make a mistake real quick and show you. If you make a mistake, like I'm going to make right now, what did I just do wrong? I put minus. You see the difference in size? The negative is smaller. Okay, if I do that and I tell it to graph, watch what it does. Someday I want it to say, hey, stupid, you can't do that. But it doesn't do that. It says quit or go to. Sometimes it just says quit. And then it says check all your arguments entered. Press plus on the menu item for catalog help if you want. So I can go to my problem and it will point it out. Sometimes it will tell me. Is it tell me right where my problem is?
Yeah.
Yes. Okay, so I'm at negative. We got to get absolute value in here before you can. Okay, negative x squared plus 8x. Minus 13. Okay, the next equation is the absolute value. Now, when I need a function, I don't know where it is, always go to math. Math is right under alpha. It goes second, alpha math. And there's fraction, decimal, cube root, cubes, all that. Go over to number. ABS is absolute value. Math, number, absolute value. Okay, and I want x minus 4 in there. Okay, math, go over to number on your over button, and number 1 is ABS. And hit enter.
And ours it keeps like the.
Yours is a parenthesis, but yeah, it has ABS in parentheses. It's just the older programming. Okay, zoom 6 again. And I want to know where they're equal, so I would have to find their what? The intersection points with the second calc.
Whoa,
Okay?
Elena's is off.
How much off?
My stuff ain't even on the same line.
Well, go back.
Did you end your parenthesis? Like you have to have your parentheses around the x minus 4. If you ended after the x, it would be completely different.
Okay,
it just
I
showed
was
me-
lost. After you go to the math part, you hit.
Math over to number, N-U-M. Math, number, and then hit enter. And yours should say ABS and have a parenthesis. Okay? The assignment today, listen, we did not get to tables, did we? So on the assignment today, just do the graphing portion. Then if you didn't finish last night's, could you check your answers in your calculator?
Yeah.
Yes.
I don't know where to go next part.
Okay.
Yeah.
So don't worry about,
Is this our assignment?
no, Tuesdays, because we had map testing yesterday.